Okay, hello everyone, it's Salor and we are in part 50 of our tutorial, a tutorial to writing a real-time operating system. In previous part, I described the body of RTOS initialize and RTOS start. And we inspect process of context switch in previous part. Okay, but in this part, I want to add some other thread system calls to the RTOS. Until now, I've just added thread create new as a system call to the RTOS. But in this part, I want to implement some other system calls that related to thread. And after that, I want to implement IdleThread. Just thread with idle priority. When there are no other threads in the ready list, RTOS run IdleThread, and you can create a thread with idle priority by using a thread create new. Okay, so let's jump to our business. I must implement all of these system calls for thread. Okay, but until now I've just implemented thread create new. But in this part I want to implement getter functions. Thread get ID, get name, get state, get priority, and get a stack size. I don't want to implement these system calls. I will add these system calls to the RTOS in future parts. At this part, I wanna implement getters. Getter system calls. Okay, but under commit number 10. Under this commit, add thread, getter system calls, and thread idle to the RTOS. I've implemented getters and idle thread, okay, and added thread idle to the RTOS. Okay. For example, if I open thread.c, for example, I've implemented get ID, get name, kernel space system call, get state, and other getters. Okay, but I have not implemented, for example, terminate or yield or other system calls than getters. Okay, so first, if you want to add a system call to RTOS, you must do these works first in RTOS.h. You must add user space system call for each system call that you want to add. In RTOS.h, include RTOS.h. I've added other system calls in this file, but at this part I want to implement get ID, get name, get state, get priority, and get stack size. Okay, and I've implemented this function, this system calls, and update in my GitHub repository. Okay, after that, in system call type definitions.h, in this header file you must add system call number, a structure of argument, specific structure, not global structure, and kernel space system call for each of system calls. Okay, include system call type definitions in this header file. Okay, I've added system call number for all of thread system calls. Okay, for each system call now I have a specific structure of arguments. For example, for get priority, we just have one argument, thread ID, get priority of the thread. Okay, and return value, all of them have return value. Okay, and for example, like before, for thread create new, name, function pointer, function parameter, priority, and stack size. Okay, and for each system calls you need to have a kernel space system call, get priority, and system call suffix. Okay, kernel space system call function has a system call suffix. Okay, after that, in kernel.c file, in kernel system call by number, you must add a case for each system call. Here in kernel.c, here add a case for each of kernel space system calls, for each system calls. Okay, here, and after that implement the system call in thread.c. We can see here in thread.c at this time just getters implemented. Okay, implement, for example, for get name user space system call and kernel space system call. But for example, for thread, for example, terminate, I've not implemented system call. Okay, and I will implement these system calls in future parts. Just I want to implement getter system calls. First, let's talk about thread get ID. Thread get ID. Here in RTOS.h, you can see thread get ID has no arguments. Okay, and when you call this function in a thread, you can acquire the thread ID of that thread. Okay, but thread get ID doesn't have kernel space system call. It's just a thread that has no kernel, that doesn't have kernel space system call. And you can call this system call thread get ID from thread when kernel is running, because by using a thread get ID you acquire current running thread, the thread that you run the system call in that. Here in thread.c you can see we have user space system call, but we don't have, for example, thread get ID system call. Okay, and for example here in RTOS include definitions, it doesn't have a kernel space system call for thread get ID, and this list is started by thread get name. Okay, thread get ID doesn't have kernel space system call, but let's to see the body of this getter system calls. Here is, you can't call this system call from interrupt, because by using of this system call you want to get ID of a thread. and you can't call this system call when kernel state is not running. If kernel is running and this system call called from a thread, return kernel get current running thread ID. Okay, because when you are in body of a thread function and the RTOS is running that thread, the ID of that thread is running thread. Okay, here. After that, other getters: get name, get a state, get priority, and get a stack size. You can see all of these functions has an argument, and this argument is thread ID. For example, by using a thread get name, you can get the name of the thread, okay, and get a stack, get priority, and get a stack size, get a state, get priority, and get a stack size. Okay, and for example, return name, return state, priority, and return a stack size. But for example, for thread get name, you can't call this system call from interrupt. If you don't call this thread from system call, you can acquire the name of the thread. Like before, put argument in a specific structure. At this time, this structure is related to thread get name. Okay, put for get name, put ID in this member. Okay, and like before, put address of a specific structure in addition of a system call number, at this time for get name, in a global structure, and call kernel system call. Okay, and in kernel space system call, acquire ID of the thread, acquire this ID from argument. This argument is a specific structure, and by using of this ID, acquire the name of that thread and put thread name in return value. And now, after returning from system call, you have the name of thread in return value. Okay, and all other getters has the same structure. Okay, put ID in a specific structure, put a address of a specific structure in addition of a system call number in global structure, and call kernel system call, and in system call kernel space, by using a thread get ID, at this time acquire the state. Okay, in this way you can implement getters, but let's see an example. Okay, here I'm in debug mode. Okay, and if I run RTOS jump to thread 1, but first by using a thread get ID, I want to acquire the ID of thread 1. Now the value of ID is 20000 and B38. Address of thread 1 control block, and here ID of thread 1, so ID of thread 1 is 2000 0b38. Okay, so by using a thread get ID, you can acquire the ID of the thread that you run this system call in that. After that, by using of this ID of thread 1, you can acquire name, state, priority, and stack size of the thread. Run all of these functions, system calls now. For thread 1, name is thread 1, state is running. Okay, now RTOS running thread 1. Priority is normal. Priority of thread 1 is normal, and stack size is 256. 256. Okay, so easy. In this way, you can implement getter system calls for threads. But now I want to talk about idle thread. A thread that its priority is idle. Okay, but let's do another time in thread.c. thread create new. Thread create new. In thread create new, because of this condition, because of this if statement, you can't create a thread that its priority is idle. If the priority of thread is idle, return null. Okay, but to create and to make a thread with priority idle, we need to implement another user space system call that add idle thread to the RTOS. And that system call, user system call defined in RTOS.c. It's a user space system call like thread create new, and by using this user space system call, you can add idle thread to ready list. Okay, like thread create new has name, argument, function, pointer, function, parameter, priority, and stack size. And you must call, and after collecting arguments in struct, call kernel system call to create a new thread. But you must call this function after initialization the kernel. In RTOS initialize, after kernel initialization, you must create idle thread. Okay, name is idle thread, function is idle thread function. The function has been defined here. At this time, this function has nobody, but in future I will add some jobs in this function. Okay, idle thread function. Priority of thread is idle. It doesn't have its if statement here like here, and you can create priority thread with idle priority, and the stack size is 256. It's not important at this part. Okay, so in RTOS initialize, after kernel initialize, you can create idle thread. Okay, but let's just see an example. Assume you doesn't create any thread. Okay, this warnings is not important, but if I put a breakpoint here in idle thread function and run the debugger. Now I'm in debug mode. If initialize the thread, initialize the RTOS, I have idle thread in ready list, but because I have no other threads in ready list than idle thread, if I run and RTOS jump to idle thread function and run idle thread because I have no other threads in ready list than idle thread except idle thread. Okay, now I just have idle thread in ready list. So here was implementation of idle thread, and enough for this part. In this part I implement getter system calls that's related to thread, and I add idle thread to the RTOS bots. But before finishing this part, let's just see kernel.c. If you want to support idle priority, you must add this equal in this condition in context switch equal to 0, because priority of idle thread is 0. And now you can have context switch when you want to switch to idle thread. Okay, and for kernel start, another time you must add this equal to this condition in this condition, okay, to support idle thread. Okay, but very good, enough for this part. Thank you very much to see me, and see you soon in the next part. Thank you very much.